Asset labeling. In the previous video, we showed how an asset was created in the system. The next stage in the process is labeling the asset with plain text and a data matrix. In this scenario, the data matrix is used to not only hold asset identity information, but the details of the product packs contained within. That is, the product code, the batch number, the expiry date, and the list of serial numbers of each contained product pack. Labeling the asset. As we can see, the aggregate has already been packed and recorded in the system. The operator selects the asset ID from the list of assets on the screen. The print label option is selected. The application will read the database to capture the asset ID and associated product packs, and then encode the data into a data matrix. The software will then print the asset's header information in the plain text label as well as the data matrix. After printing the label, it is applied to the asset. There is also an option to encrypt the data before encoding it into a data matrix. This facility allows the manufacturer to share sensitive information with members of its supply chain who have the appropriate key and seriological software to perform the decryption. As before, the operator highlights the relevant asset, but this time chooses the encryption option. The application will then encrypt the data before encoding into a data matrix. The plain text label content will remain as before. From a distributor's perspective, the data matrix provides two major benefits. Firstly, on receipt of the asset, the distributor can just scan the asset's data matrix to get the asset header data and the list of product packs contained within, without having to open the asset and perform a manual read of each product pack data matrix. Secondly, the distributor can choose to generate a file of all the product packs, which can then be passed on to the bulk product pack verification software to verify each of the product packs against the NMVS. We now move on to tagging the assets with an RFID tag. First, we retrieve an RFID tag and scan this using a handheld RFID reader. The tag identity is displayed on the reader's screen. The operator selects the appropriate asset from the assets table on the screen, and then accesses the drop-down list of RFID tag IDs. The operator then selects the same ID as that displayed on the handheld reader. The tag is now associated with the asset, and the tag is applied to the asset. We will now demonstrate labeling in the lab. In this example, the operator selects the asset and the print file button. He then creates a print file name based on the asset identifier. The PDF file is then printed to produce a plain text label and the data matrix.
Stop it. Move it a bit.
It is worth considering some of the implications of using data matrices. First, the asset data matrix dimensions correlate with the volume of data encoded. 2. For plain text encoding, this should not cause any problems with label sizes or encoding and decoding times. Thirdly, the encryption option generates additional data in the data matrix which impacts the dimensions and the time to encrypt, encode, and decode, decrypt. And finally, Serialogical have performed some preliminary investigations on encryption algorithms, encryption parameters, and their impact on performance and label sizes, and will be happy to share this once completed. Mapping the tag ID to the asset ID. Having selected the RFID tag, the operator then reads it using the handheld reader. The tag ID is displayed on the reader's screen. The operator then accesses the PC and selects the relevant tag ID from the drop-down list and associates it with the asset ID. The tag is then applied to the asset.